So the question is simplify 5 raised to 2 into n plus 6 into 25 raised to negative 7 plus 2n upon 125 raised to 2n. How many terms are there in numerator? Only single term. How many terms are there in denominator? One term. There is no sign of plus or minus in between the factors, means entire given question is a single term. So you don't need to factorize if it is single term. You just make the base same. 5 raised to 2 n plus 6 as it is. 25 can be written as 5 square. So 5 square bracket negative 7 raised to negative 7 plus 2n as it is. 125 can also be factorized as 5 cube. So 5 cube raised to 2n as it is. Now you apply the rule, power raised to power. You multiply both the powers. So power raised to power multiplication. 5 raised to 2n plus 12. Power raised to power again multiplication. 5 raised to negative 14 plus 4n. Denominator also power raised to power 5 raised to 6n. Now you have same base in numerator and denominator. Whenever same bases are multiplied, their powers are added. A raised to m into a raised to n, a raised to m plus n, and when same bases are divided, the powers are subtracted. So use that rule here. Five raised to 2n plus 12 plus negative 14 plus 4n minus 6n. Now simplify like terms. 2n plus 4n, 6n minus 6n, so cancel. 12 plus minus minus 14, so 12 minus 14, 5 raised to negative 2, 1 by 25 is your answer. So unlike previous question, this question has two terms in the numerator and two terms in the denominator. So your first step will be factorization of numerator and factorization of denominator, and when you have variable in the power, try to get a common base. 27, 3, 3 and 27. At these four places the powers are in variable, and these four numbers are some power of 3. So we can convert these four numbers with base 3. Keep remaining numbers as it is. 3 into 3 cube raised to n plus 1. 9 can be written as 3 square, but there is no variable, so we will keep 9 as it is. 3 raised to 3n minus 1 as it is. 8 into 3 raised to 3n as it is, minus 5 into 27 is 3 cube raised to n. Now at these two places, apply the rule power raised to power multiplication. 3 into 3 raised to 3n plus 3 9 into 3 raised to 3n minus 1, 8 into 3 raised to 3n, 5 into 3 raised to 3n. If same bases a raised to m into a raised to n are multiplied, powers are added. You know this rule. We can apply that rule here in the first term. We can convert 9 into 3 square and then we can apply that first rule. But what we are doing is we are trying to simplify, and for this type of question we will try to eliminate the variable. So this part 3 raised to 3n plus 3, you use the same rule from right hand side to left hand side. Same thing over here. So that can be written as 3 into 3 raised to 3n into 3 raised to 3. 3 raised to 3n plus 3, we are dividing that power into two bases, 3 raised to 3n, 3 raised to 3. Similarly, 9 into 3 raised to 3n, 3 raised to minus 1. You can write it as upon 3 raised to 1, but that will make a complex fraction. We already have a fraction. Then we introduce a fraction in the numerator. So fraction in a fraction is complex fraction. We'll do it in the next step. Upon as it is, because we no need to apply that rule in the denominator. So 8 into 3 raised to 3n minus 5 into 3 raised to 3n. Now factorize. Whenever you have two terms in numerator, two terms in denominator, you factorize. Factorize means taking out common. And we will try to take out common those factors which has variables. Other factors are also common, but we are not taking out the highest common factor. We are just trying to eliminate variables. So 3 raised to 3n common, 3 raised to 3, 27 into 3, 81 plus 9 into 1 upon 3. 3 raised to negative 1 means reciprocal of 3, 1 upon 3. Denominator 3 raised to 3n common, 8 minus 5. So 3 raised to 3n common factor is cancelled from numerator and denominator. 3 one time, 3 three times. So 81 plus 3, 84 upon 3, 28 is your answer. So the question is simplify x raised to 1 upon 3 minus x raised to negative 1 upon 3 in one bracket, another bracket x raised to 2 upon 3 plus 1 plus x raised to negative 2 upon 3. One of the ways to solve this, simplify this, is use distributive property. You have two brackets to multiply, use distributive property. But if you see these numbers and powers, first of all, any number raised to negative power is reciprocal of base and the power is positive. So first if we apply that, x raised to 1 upon 3 minus 1 upon x raised to 1 upon 3. A raised to m whole raised to n. A raised to m into n. Power raised to power is multiplication of two powers. We will use that in reverse way. In the second bracket, if we ignore the minus sign, the powers are, both the powers are 2 upon 3, and 2 upon 3 can be written as 2 into 1 upon 3. So if we apply that power raised to power rule, x raised to 1 upon 3 square plus 1 as it is, negative powers or reciprocal, x raised to 1 upon 3 square. Now in this step, you will see the same variable with the same power at multiple places. X raised to 1 upon 3, denominator x raised to 1 upon 3, second bracket x raised to 1 upon 3, x raised to 1 upon 3. Same variable, same power means the same factor is appearing at 4 places. You assume x raised to 1 upon 3 as a simple variable. Repeated appearance of this complicated term can be replaced with a simple variable for simplification, and at last you replace that. So this will be y minus 1 upon y square plus 1 plus 1 upon y square. So this is in the form of identity a minus 1 upon a square plus a into 1 upon a, which is 1, plus 1 upon a square. And the answer for this identity is a cube minus 1 upon a cube. So answer to this will be y cube minus 1 upon y cube. Now we replace what we had assumed. If x raised to 1 upon 3 means cube root of x is y, then x will be equal to y cube. When you transpose cube root to right hand side, it will become cube. So y cube equals to x. So your answer is x minus 1 upon x. If you have gone through all the rules of indices, we do not have any rule for addition and subtraction of different bases. So we cannot apply any of these rules in these two brackets separately. But if you look at the individual term, they have negative powers, and we have the rule for negative power a raised to negative m. You reciprocal the base 1 upon a raised to m. We do not have any rule for addition and subtraction of different bases. So 1 upon a plus 1 upon b divide by, you can write upon, divide by means you can write upon also, but upon 1 upon a square minus 1 upon b square. Now you follow the rule of BODMAS. First you simplify the brackets. Inside the brackets you have fraction. So fraction can be added and subtracted by taking LCM. So in first bracket LCM will be AB. So you need to multiply here B, you need to multiply here A. So your first bracket is B plus A upon AB divided by, again LCM in the second bracket, multiply B square to the first term, A square to the second term. So B square minus A square upon A square B square or B square A square. Once the brackets are simplified, you can apply this division step. Division of two fraction means multiplication of the second one, reciprocal of the second one. So b plus a upon ab multiplied by a square b square upon, you can apply one of the identities over here, b square minus a square, b minus a, b plus a. So now what is left is I am just rewriting this step, b plus a in the numerator and ab in the denominator of the first fraction multiplied by a square b square in the numerator, b minus a, b plus a in the denominator of second fraction. Everything is in the multiplication. You can cancel out common factors. B plus a common, cancel. One time a is cancelled, one time b is cancelled. So what is left is ab in the numerator, b minus a in the denominator. Prove that x raised to a upon x raised to b whole raised to 1 upon ab into x raised to b upon x raised to c whole raised to 1 upon bc into x raised to c upon x raised to a whole raised to 1 upon ac equals to 1. For prove that type of sums, you start with one of the two sides of the given equation. So start with left hand side, which is more complicated compared to right hand side. X raised to a upon x raised to b whole raised to 1 upon ab, x raised to b upon x raised to c whole raised to 1 upon bc, x raised to c upon x raised to a whole raised to 1 upon ac. Now you can proceed in two different ways. Either you use a raised to m upon a raised to n equals to a raised to m minus n. You use this rule inside the bracket, or you use a upon b whole raised to m is a raised to m upon b raised to m, distributive rule for powers. You can proceed with one of these two ways. We will do the first one. X raised to a minus b whole raised to 1 upon ab, x raised to b minus c whole raised to 1 upon bc, x raised to c minus a whole raised to 1 upon ac. So now power raised to power multiplication. You have to multiply these two powers. Similar multiplication in all the three brackets. Just see this multiplication. A minus b multiplied by 1 upon ab. In all the three brackets, the multiplication is similar. All the three brackets multiplication is similar. A minus b in the numerator and ab in the denominator. So denominator can be splitted to both the terms. This will be a upon ab minus b upon ab. A cancel in the first term, b cancel in the second term. What is left is x raised to 1 upon b minus 1 upon a. Identify the pattern. Here it was a minus b. What is left is 1 upon b minus 1 upon a. So apply that pattern in the second one. X raised to 1 upon c minus 1 upon b. X raised to 1 upon a minus 1 upon c. Same basis in multiplication. Add the powers. X raised to 1 upon b minus 1 upon a plus 1 upon c minus 1 upon b plus 1 upon a minus 1 upon c. any number raised to 0, answer is 1, which is the right hand side of the given equation. Hence, the given question is proved.